So today we will be talking about solubility. This time, the solubility we are going to be looking at, we're going to be solving the problem on solubility by titration method. Now, what is actually solubility? One might even wonder what is this solubility all about? When we're trying to find the solubility of a substance, a solvent in a solute at a particular temperature, what we're trying to find out, what we're finding out is the maximum amount of that solute that will saturate 1 dm³ or 1000 or 1 liter or 1000 cm³ of that solvent at that particular temperature, and it will be what in mole or in grams. So that is what we are always looking at for. So which means solubility is always measured in mole per dm³ or in gram per dm³. Now in this analysis we are able to carry out experiments, and then this is the table of value we have here, and these are the information given to us, and we are expected to solve this problem to calculate the concentration of B in mole per dm³, and then solubility of sodium triisocarbonate carbonate 4 at 30 degrees Celsius. This is the temperature we are trying to, the temperature we're looking at this in regards to this solubility. So here, so what are we doing? We say that A contains 0.123 mole per dm³ of nitrate 5 acid, and then B is prepared by diluting 25 cm³ of a saturated solution of anhydrous sodium triisocarbonate 4 at 30 degrees Celsius. So 1 dm³ with distilled water. Now, this is the table of value for the titration. We have everything we need here. But before we carry on this thing, there's something I want you to understand. We say that 25 cm³ of saturated solution, meaning that this 25 cm³ has the maximum amount in grams or maybe in moles of this sodium triisocarbonate that should be here. So meaning that since it has a maximum amount, and then we dilute it with distilled water to get it to 1 dm³, meaning that whatever amount we have in this 25 cm³ is equal to what we have in this dm³. It's equal to the amount we have in this dm³. So this dm³ is not going to generate extra amount from anywhere. Remember, I said in distilled water. So what means now the first question? Let's just quickly go through the questions. So here, the first thing we do here from our analysis, we were able to get this information. So what are we doing next? We're going to take the average. Looking at this, it's always nice to take the average, to take the average, take the value that is to be somewhat related close to each other. That is to say, if you look at this finally, find out that we have a 26.550, 26.50, 26.40. So if you look at, they are almost very close to each other. So we can decide to use all, or maybe use these two that are together. But anyway, let's just see what we can. Let's use all of them. If we're using all of them to calculate the average volume of A used. So that will give us, we have plus 26.50 plus 26.50 plus 26.40 all over 3, just by finding the meaning. So what do we have next? If we add it up together, point plus 26.4, we'll have 79.4 divided by 3, we have approximately 26.47 cm. This is the average volume. That's what we're going to be using to solve this problem. The first problem here says that we'll calculate the concentration of this solution B in mole per dm³. Now, like I said, When you get this concentration of B in mole per dm cube of this solution that is made up to what 1000, it means that uh, you have already gotten what we have here, the amount of sodium triazote carbonate that is contained in this, because this maximum, this 25 cm cube contain the maximum, the maximum it can dissolve at that very temperature. So for that reason, whatever we have here is telling us what will saturate 25 cm cube of sodium triazote carbonate at that temperature. So that's what we're going to be doing now. Let's see how far we can go with that. We have our volume of the equipment here. Pipette is what 25 cm, and we use metal rate for doing this. So let's see how far. That means 25 cm cube will serve as the volume of the bead we use. So and then we can now use our normal formula, that is CA, CB, VB, all over CA, CB now, CB, C, VB equal to. Now from our balanced chemical equation, now look at this very well. You find out that we have two here. These two stand for the mole ratio of the acid. Why this other one? Because it has no unit, no number here. That means it means one, because one times any number will give us one times x will give us what? X. So for that reason, this one, the mole ratio here is one. So for this other end of it, the mole ratio. So for the volume of A, volume of A is what? Equal to 26.47 cm cube. Now the volume of what am I doing? Concentration, okay. This is volume of A. Concentration, concentration of A now, which is 0.123 mole per dm cube. So the volume of B, which is 25 cm cube, 25 cm cube. That's what we have there. So we are going to get the um, concentration of B, which we don't know. Remember, I told you something about this. I said that once you are able to calculate this, that means you have been able, you are now, you've been able to get, it means that you have the volume, the maximum amount in moles that dissolve, that saturated with 25 cm cube of that solution. So that's what we're going to look at now. Let's see how we're going to solve this problem. Our A here will then be 2, while our B will be what? 1. So when we substitute everything we have here, if we are substituting, what we have here will be for the concentration we have times 26.47 all over times 25. This one will equal to 2/1. So we have all the values we need. I think we can clean up this place. So all the values we need are here. So the next thing we are going to be doing now is to compute the whole thing. 2 we cross multiply. 2 multiply what? Multiply 25 and CB. We will have 50 CB, and we have 0.123 times 26.07. So if we what we do here is, okay, CB will then be times 26.47 all over 50. So 26.47 times 0.123 divided by 50. It will give us 0.056 approximately mole per dm cube. So this is what we have. This amount we have here stands for what saturated the 25 cm cube. So now remember, in solubility, we will look at what saturates 1 dm cube in 1 dm cube, or gram per dm cube, mole per dm cube. So for this reason, now we are using this information. The second question says solubility of sodium triazote carbonate at 30 degrees Celsius in mole per dm cube. Now to find it in mole per GMQ, because what we are giving here is not really in mole per GMQ. What we have here is concentration of sodium tricarbonate that we have in 1 GMQ of the solution that we diluted. So when we now what we have here is what saturated this, like I said before. So what it means now, 25 cm3 saturated, let's say equivalent to what? It's equivalent to 0, 0, 0.005 mole. That's what we have there. So what will 1000 cm3 contain? 1000 cm3. Now, why am I using 1000? Because 1000 is equal to 1 GMQ. So that means since this one is in CMQ, so we need to use this unit here to get it. This if equivalent in what GMQ. That is why we're using it. So it will be equivalent to what 0.065 all over 25 times 1000 over 1. So what do we do now? Let's see what you're likely to get. Times 1000 divided by 25. So what we have here, the solubility is 2.6 mole per GMQ. Always remember to put the unit of this because it's very, very important. And this is where we'll come to the end of the class today. Thank you so much for being part of this class. And if you are joining us for the first time, we want to encourage you to subscribe. Subscribe so that you will always get the best of us each time we upload. Now, I would love if you have any question and if you want to hear from us, you can also leave your comment there. You can leave your comment and you can also visit our Facebook page or um, S channel where you can also access us. So I want you to share. Let your friends know about us and what we are doing. Thank you so much.